Thomas, are you there?
Hey, DaShaun, how are you doing?
Yes. Isn't technology amazing?
It is.
I'm having a lot of fun already. And
Yeah,
I'm excited to get to do this with you again. One more time. We're taking it on the road.
Right. Okay. So things have changed slightly, but I think we're moving. Let's just recap a little bit what we've been talking about. So I mean, move the slide. So we're basically talking about scaling to zero, right? So, and we found a tweet from Kelsey Hightower where he says it's a trade-off. It's not necessarily best practice, right?
Yeah.
It's not a free lunch.
It's not a free lunch, right? When we're in this age of we're being billed per millisecond, and milliseconds matter, not just to our bill, but also to our customers. So yeah, it's a trade-off, right? We can either answer the call or we can scale up, and it's sub-second in a lot of cases, but still, it is a trade-off.
And you have to do a little bit of work to get to that point as well, right? And
yes, indeed.
it might slow you down in other aspects while your app starts up faster.
Yeah.
So in general, like it's part of serverless idea that things start up quickly and then go away, and you're not paying for stuff that you're not using. And it's on Kubernetes, we typically see this with Knative, and there's also something called Kata, which will scale up and down your pods. Which
I love Knative serving so much that I haven't even Kata for a spin yet. So yeah, I'm happy.
I think Kata gives you more options. Like you can scale on like message queue length and things like. Knative typically is HTTP requests, so if you don't have any requests, your app can scale to zero. But if you do get one, it scale it back up.
There you go.
But it's not limited to functions. You can do a whole like a Spring. One of my demos is a Spring Boot app called Spring Pet Clinic, so you might all be familiar with. So that's like a full web app, and that can also be scaled to zero and scale back up as requests come in.
Which is amazing.
Yeah, and it's great that we pay as you use billing model. Like you only pay when you're running something, when you're processing a request, and you're not paying much when you're idle.
Yeah, and we're being billed per millisecond. So scaling up, scaling down, and scaling back up, right? Those milliseconds matter.
So today we're talking about 2 ways to scale your Spring app to zero and get the sub-second startup for that. And one has been around a little longer, which is scaling to zero using the native support in Spring Boot and GraalVM. And I'm sure you've used that, DaShaun.
I've used it quite a bit. And in fact, I remember, I think it was something similar to this, a Spring One Tour kind of thing. It was Dr. DeSire was on, and he was kind of talking about the plugin, the Spring Boot Maven plugin and its native option, how we could do this and start to build these images and digging in it. But I remember saying, hey, I would like to build these native images using what was called, I think, Spring Native was the experimental package. But I remember thinking, oh, I want to do this. I want to go and play with this. But I got a bunch of Raspberry Pis. So I remember it very, very well. I got excited about it early. The idea that I could take my Spring Boot apps and not just have the fast startup time, but have the really small footprint that could run on these single board computers.
Yep. So it's an alternative to your classic hotspot JVM that takes a bit of time to scale up, but then it does improve performance as it runs for a long period of time because it does all these hotspot stuff on it.
When I think of hotspot, did hotspot come around like in Java 4? It's been around for a long time.
It's been around for a long time, yeah.
And the way that I remember, the way I think about it is like, hey, the hotspot was like, hey, I see where you're doing this a lot, and we're going to optimize that, and we're going to optimize it all the way down to the machine code, the native code for whatever platform you're running on. And the JVM was doing that for us. And then at some point we were like, hey, well, why don't we just do that for everything? Do it ahead of time.
So if you take the Pet Clinic and compile it as a native app, it really here's where you're running it locally. It's 0.107 seconds. So that's like 0.1 second. That's pretty quick startup.
And for those that don't know, the Pet Clinic is kind of a well exercised application that kind of demonstrates a bunch of the things that we are typically doing in enterprise applications.
we'll see this pet clinic in action during my demo. So.
Wonderful.
So the GraalVM advantages is basically an instant startup, and there's no warm up, right? Because it's native code.
Right.
There's no hotspot features, but it uses a lot less memory, and the images tend to be smaller than your regular JVM images.
Yeah, the OCI images that we're building, right? The footprint, the jar, I think, is actually bigger than what we might get in that native image. But when we deliver these things in OCI images, there's no JVM being delivered. So when you look at if you're on Windows, it'd be a .exe file compared to a jar file. The .exe file might be a little bit bigger than the jar file, but the image that you're making has its base layer, and then its runtime. If you're delivering the jar file, you've got to deliver that JRE along with it. And what we're doing the native images is just the base image, that base OS, and our application layer. So yeah, if you're doing things at scale, those container sizes, right? In GraalVM, we're being paid per millisecond, also paid per byte that we're sending over the wire across the globe. So yeah, these things all matter.
But when you build a native image, everything goes into the build time. So there's no runtime loading of stuff, which in a sense reduces the attack surface of your app, because it's baked in and nothing gets added while you're running. While in a regular JVM app, depending on how you code it, but it's possible that you load something that you have to be careful with.
Right. And that's all, again, it's another one of those trade-offs, right? Before we had this native image capability with Spring, we were kind of faced like, oh, well, everybody's, the startup time over here is smaller and the footprint over here is smaller. Now we get rid of that. The trade-off is we're going to trade away some of those dynamic capabilities that we get with the JVM. And it's awesome, right?
But they're trade-offs, right? Yeah. There's no compilation takes quite a bit of time.
So we're going from sometimes seconds to minutes, depending on what we're doing.
Yeah. When I compile the Spring Pet Clinic locally, it takes about 3 minutes for a full native build.
Well, when I started doing the native images, with the early versions of GraalVM, the compile times on a Raspberry Pi were taking 4 hours.
Whoa.
So I'm very, very happy with all the work that the GraalVM team has done. I'm now even more excited because when we're noticing seconds and we're doing these things all the time, I'm also seeing some of those build times improve as well. But the thing is, the build time, like we're going to do that once. It's going to start up. It's going to be deployed more than once typically. Yeah. So that trade-off seems to be worth it. I'll take that 3 minutes of build time that's happening on my supply chain anyways. I'll take that time. And the trade is I get a smaller footprint. I get the faster start. I get all the other benefits. So I think it's a good trade.
And since everything happens at build time, whatever libraries and things you use has to be able to participate in the native build process to get every class that you're going to need to load it in at build time rather than runtime.
A trade-off.
It's a trade-off, and sometimes you have to provide extra settings for the build to actually realize where your config file might be located, because otherwise it doesn't get loaded automatically at runtime. Yeah.
The GraalVM doesn't know everything. With Java, with Spring, we have this ability to do proxies and reflection, and GraalVM sometimes it needs a few hints on where things live, and we can give it that.
Yep,
that works.
And we saw this tweet a little while ago. There was someone who migrated their web app from the regular JVM to using GraalVM, and you can see the drop in the memory usage is drastic, which kind of pays for for memory while you're running things in the cloud, right? So that's pretty impressive.
Usually the memory footprint, right? Disk is cheaper, when it's being unused. The memory footprint, the RAM, is typically the most expensive part of what we're doing in the cloud. CPUs and cores that can catch up quickly, but the memory is usually the most expensive part of what we're doing. And the interesting thing here is we've got use cases. We've been doing this long enough now. It's going to come up on a year since it's been GA. And we've been doing this, and the trade-offs that we're making, the native images aren't always going to perform better, right? There's some workloads where they're actually going to perform better on the JVM. But even then, the footprint, the smaller footprint, the faster startup time, sometimes it outweighs the performance difference. And we've seen that from customers. So we've got another dimension that we need to kind of evaluate before we take things to production, or after taking our app to production. Run them side by side. Run the JVM app, run the native image, and compare. See how they do.
And one thing, typically the AOT JVM apps were performing slightly better than the native ones, but I think with the latest Java 21 release of the GraalVM, they're actually closed the gap, or maybe even surpassed the AOT.
Yep. It all depends on your
or the hotspot JVM. So,
and I put this into the same kind of bucket as my garbage collection, right? How often, I had this conversation last week, how often are people evaluating which garbage collection to use for their workload? We can kind of take the defaults and it'll work most of the time. But I look at this as kind of another one of those comparisons. Another thing that we've kind of got to reevaluate as we're going to production. Make sure even if you go down the native image path, just reevaluate it. Give yourself that confidence. But I put this into the same bucket. Yeah, evaluate your assumptions.
So you want to do a little demo?
I would love to see your new demo.
I have the pet clinic. So I have checked it out already, and I made one slight modification. I added DaShaun's builder. Do you want to give us a brief intro
what
to
timing? So you and I are both on an ARM64. I talked about my Raspberry Pis.
Yep.
So I spent a lot of time building this ARM64 builder. What I basically had to do is change the stack that these build packs are running on, because when you're building native images, the native code, it's only going to work on the operating system and the architecture that it's built for. So I can't take something built on my x86 machine in Windows and run that on even x86 in Linux with the native image. It's got to be the same operating system and architecture, because we're building this native code. So anyways, I created an ARM64 build pack because I love build packs, and you should too. Friends don't let friends use Docker files. So build packs is the way to go. But I created this, and earlier today, I got the news from our coworker, Anthony, that the pipelines that are building everything for the Java build packs, Java and the native Java build packs, there's been a PR that's been submitted that has all the things in it for ARM64 support upstream and Paketo. So the release that I did this morning might be the last release of my ARM64 multi-architecture build pack that I'm ever going to do, because it's coming fast. Upstream Paketo, they're working hard, and we might have the support. And it'll be for Java first. So yeah, stay tuned on that. It's an exciting day.
Does that mean if I do this in a week from now, I would not have to add this?
Correct.
Profile.
Fingers crossed. Fingers crossed.
Cool. Yeah, I'm looking forward to that. So I'm going to compile this Spring Pet Clinic native compile, and I'm started up a quick start of a kind cluster running Knative serving.
I love Knative.
And if you're interested, let me pull this up here. And so I have everything in my repo here. Spring One Tour 2023 has a README, links to all this stuff you need to install, has links to the demos. So this is the Spring Pet Clinic as native build. And it tells you exactly step by step. So if you want to go to that repo, give this a try on your local machine.
And let us know how it goes.
Yes, definitely. File an issue.
Or
if it doesn't work, file an issue. We'll figure it out.
Yeah.
So I already started up the Knative cluster. Now, one thing I have to do is I built the image. So it took 3 minutes.
Took 3 minutes. Okay.
Now I need to load this into my kind cluster, because I don't necessarily want to put this in a registry, in a public registry. I just want to keep everything local. But I do have to load this in.
So you've eliminated the need, right? Knative serving normally wants to pull things from a registry. And
Right.
all you've done is say, hey, load this image from my local machine,
Kind
load
cluster.
this into
Yes.
Kind Cluster. Okay.
And the key here is I put dev local as the registry
Okay.
prefix. And that means that Knative sees dev local and he says, okay, there's no registry here. I don't have to go out and check for it. If you put something else there, it will fail because you can't find the public image. So I typically put dev local in front of it to make it easier with Knative to deal
You
with.
showed me a cheat code. So I do use Knative serving on my laptop and on my daily driver, but I use K3D to deploy it. So I'm not using Kind. So I still need to figure out like, hey, can I do that without Kind? How do I load that image into my local registry? I know there's other workarounds, but yeah.
Yeah.
You have my head turning. Thank you for that tip. That's a nice tip.
Yeah, you just kind load and the name of my cluster and the image name, which I put in the environment variable. Just so now I can actually deploy this as a Knative service.
So this YAML is just defining what we're doing.
Yes, this defines the Knative service, the image. Oh, I also have a database. So I need to start that up. I just use Helm to install.
As you should.
Postgres.
Helm's a great tool.
Yeah.
It's been around. Another great tool, CrAC. I love CrAC packages as well. You might have missed it. You could check out Lee was going to talk all about CrAC on the other channel.
So this
I'm sure you can watch it later.
Yeah. So this installed a Postgres database I can use. And actually for the data source password, I pull out the secret that was created from Helm to actually get the password so I can connect. So
that was easy.
It should start up. Since the image is already in Kind, it starts up pretty right away. It doesn't have to pull the image, doesn't have to do anything. It's very quick to start. And we should have pet clinic running here. You can find the owners. You can add a new pet. Let's see, he's born yesterday. And since this is a Postgres database, if I scale to 0 and scale back up, like typically Pet Clinic uses an embedded database. So once it scales back up, your data is gone.
So can you show me your pods that are running right now? Because you showed me the service list. Can we take a peek at those pods?
Yeah.
All right, it's running.
2 pods. There's the Postgres pod and the Pet Clinic pod.
So now what I expect, the whole scale to 0, I think the defaults with Knative serving, I noticed you didn't put any changes. I think it's 60 seconds.
Yes.
Right?
Yes.
So if we don't do anything for 60 seconds,
it will go away.
It'll go away.
Yeah.
As long as we don't make any more requests.
Right.
So we'll hang out for 60 seconds. That works. Simon made the comment about pull and run. Yes, we just want to pull and run. Let's go. Git clone run. Right? We can do a lot of cool things where we don't have to do a lot of setup for our environment. This is the way that we're doing software right now. And one of those other tenets, we want to be developing against an environment that's similar to what we're doing in production. So running Kubernetes, running something like Knative serving locally, when your images can scale to 0, it's not just about production, right? The work that you and I are doing, if I want to have this running and have this demo, look at there, it's terminating.
All right. So if I go over here, do another find owners. It started up another one, right? We go back here.
There it is.
We got a new one running.
Amazing.
See different pod ID. So,
and for local development, the point is I can have a bunch of this work that we're doing locally. I don't need everything up and running all the time. I can save some of those resources and I can have it scale up. When you just hit that URL, I didn't notice the difference, right?
Right.
But I'm also,
it's pretty quick.
Yeah. And the milliseconds on my laptop don't matter. Right?
And the beauty of using Postgres as a backend database is my bird is still there.
Wonderful.
That's the important part.
Amazing.
And we could check the startup time. And it was pretty quick.
Yeah, I always look for the number in parentheses. And even though I have my glasses on, sometimes I have a hard time finding it.
Here we go.
There it is.
0.293 seconds.
I can live with that.
I can live with that too. So that's our quick Spring Pet Clinic demo.
That was great. So what we didn't do was we didn't look at the runtime of that, right? We can do a demo. We can kind of show the difference in the footprint, but we didn't show it for this. Maybe we'll do that on the next one, because I imagine when we're building these native images, the footprint of the native image, like how much resources it's using, it's not just about the fast startup. The native image also provides this benefit of the smaller footprint that we talked about already. And sometimes that difference is orders of magnitude. Many times it's orders of magnitude. So yeah, fantastic. But we got more options.
Yeah. So this brings us to the second option. That's a new development. We can scale to 0 with just using a regular JVM, or not regular, but a JVM without the native compile. And with the new project CrAC, which is coordinated restore at checkpoint.
Yeah.
And it's an experimental thing. It's supported by Azul has an implementation, and hopefully we'll get into more JDKs as we move along.
Yeah.
And it's coming, support for it is coming in Spring Framework 6.1 and Spring Boot 3.2, which is
right around the corner.
Out next month, I hope. Yes.
Right. The RC. So if you want to help us out, you can take the release candidate for Spring Boot 3.2. I think it's coming out in like 6 days, right? Next week, sometime 23rd, 24th, real soon. So take those release candidates out for a spin. Yeah. Exercise some of these new cool features. I remember sitting in the audience and hearing about coordinated restore at checkpoint for the first time, and my head was racing. I'd been doing the native image stuff, and I'd kind of learned to live with the constraints, the trade-offs, the build time, and the closed garden, and not being able to take my workloads to different places. I had to change my configs, and I had to do new builds for the different configurations that I wanted to run. And then I saw this demo. I saw the coordinated restore at checkpoint, and man, I got excited because less trade-offs. That's what they're doing. They're making it so I can still have all the benefits of the JVM. Again, my footprint's not one of those trade-offs. I'm not going to get the benefit of a smaller footprint by going down this path, but I can scale to 0 and I can scale up quickly and have all the benefits of the JVM. Oh, that's so nice.
So basically the idea is you start your app, you take a snapshot, and the next time you start it, it starts from the snapshot, and it's pretty much as fast as your native startup. So it's sub-second. And there's certain things that your libraries have to do, like if they open connections, you can't leave them open when you take the snapshot. So you need to make sure that everything is closed. So it has to work with the Spring lifecycle, the bean lifecycle.
Yeah, the feature, this snapshot, this is something that got introduced into the Linux kernel, if I'm not mistaken. So yes. What it's doing is it's taking a snapshot of all the processes. Here's where our current state is, and it's writing it down to disk or including the platform, right?
The whole memory,
right?
Content, so everything.
There's some, you can't just say, hey, here's a snapshot because of the things you just mentioned. There's connections, there's database connections, and other network connections. So if you just take a snapshot, anybody that's done any kind of networking knows what happens when we unplug the network and plug it back in. Sometimes there's issues. So the Spring team, the amazing Spring team, has made it so that we can still get this snapshot support, but it does all of those things that I don't want to worry about, things that I forget about until it is important and I've broken production. The Spring team is making it so that when we take this checkpoint, we're getting all of the connections into the right state. It's doing all of the events, the necessary hooks to make it so we have a clean snapshot into our platform that we can start up from. This is amazing. I don't have
But
to
that
think
means
about
all the various Spring projects have to support this, and there's a web page where you can check the status of the latest
it.
and greatest.
Amazing. So this is great. I'll take that trade-off.
Yeah.
I want that benefit.
So you start up your application, let it warm up a little bit. Then you stop the application context, which means that everything gets closed, all the connections, files, JDBC pools and everything. The snapshot is written to disk, including memory with all your passwords and everything. So you sort of have to treat those snapshot files with care.
So that's a warning, right? So
Yeah,
if we're doing this, excuse me, and you're taking that checkpoint, you might not want to put all of that checkpoint into a container and then put that into a public registry.
Correct.
Might not be the best idea, because
Not
then
a
somebody
great
else
idea.
can grab that and go. So in my head, you kind of want a platform that'll handle that for you. You want someplace where, hey, that is going to be written and encrypted and taken care of as it should be.
Yep.
You'd like to have that taken care of for you. So yeah, it's an important piece. Lots of awesome, amazing things, but tread lightly.
And when we start it up, so it restarts the application context, so all these connections and pools and everything gets recreated, and application kicks off instantly.
And that's
Very
amazing.
cool. So here's a demo of the pet clinic that I think Sebastian did this. And so typically it starts up in 3.4 seconds. And then it takes a checkpoint, and next startup is 50 milliseconds.
And when I typically do this side by side with native images, honestly, a lot of times the coordinator store, the project CrAC, that startup is actually faster than my native image. Just like we saw here. When we did the demo last time, it started up so fast that we were like, whoa,
Yeah.
Did it work? Yes, it is that fast.
So the advantage of Project CrAC is instant startup. You don't have to warm up because that's already been done before you took the snapshot. And it's still basically running a JVM. So you're not locked into the native restrictions as much, although your libraries have to support closing the connections and all that stuff.
Yep.
So it's not it's not a free lunch. You have to make sure you pick and choose what libraries you use and that they can take part in this snapshot restore lifecycle.
Yeah. Can we go back one slide?
Yep.
The runtime warm up, right? We talked about the hotspot, being able to identify like where your code would need to be optimized and where it could do that.
Mm-hmm.
We're going to get some of those same benefits. I believe that what we're going to have is an ability to decide. Maybe we don't want to just wait until things are healthy and connected. Maybe we want to wait until our cache is primed, or we have some other milestone. So we can, I'm assuming we can move that checkpoint. We can say, hey, I'd like that checkpoint to happen at this point in time instead of here. And you'll see that in some of Sebastian's demos where we can kind of move when that checkpoint is taken. And this is super valuable. So you could actually like move that checkpoint to after we've warmed up the JVM. Right. And then you can get all the benefits, which is, again, absolutely amazing.
Yeah, the only drawback is that now you have a pause when your checkpoint happens, and then when your app starts back up, so there'll be a bit of a lag there.
Yep.
But yeah, definitely things to experiment with, which is basically where we are at with the CrAC support, right? It's right now we're experimenting, and ideally we have support in the platform where you have this part done as part of the build of your app and then deployed based on using the snapshot.
Yep. I said I want it now. As soon as I saw the demo, I said I want it now, and I was going to go the wrong way. I was going to have that as part of a build pack and write the snapshot to a container image, and then let the build pack keep going and pull up. But what I would have been doing wrong, I got my hands slapped, and I got the warning was all of your secrets and stuff will be there. It's got to be a collaboration between the application and the platform. And it has to be secure, right? It's got to be secure first and secure by default. So it's definitely going to take a coordinated effort in order to do this right.
Yeah. and it's also only supported on Linux. So if you're running on a Mac, you have to run a Docker image with a Linux. And if you're in Windows, same thing.
Yeah, we can
But
figure that out.
typically, most cloud deployments would be on Linux anyway.
Yep.
So it's
And
not
that's okay
such
for now.
Yeah, that's
right. Our Spring Boot apps are going to run just fine on a Linux operating system.
And this brings us to another demo.
Wonderful.
JVM checkpoint restore. Again, I have a little to-do or a step-by-step how you can just build an app and add in all the support you need for doing it, playing with CrAC on your local box. So you basically do a curl against the start.io, start.spring.io.
Okay.
Create
I
a
love
basic
it. You're
project.
using Milestone version.
Yeah.
Wonderful.
Yeah, I'm using the 3.2.0 M3, which is the latest that I could find. And that's the one that has the CrAC support built in. So basically unzip it, add the CrAC dependency is the only new dependency I have to add. There's an org.crack on GitHub. And I grabbed the latest version they had out there. And then I just add a basic MVC controller that says hello. And I need to add a Docker file. That's a tricky part here because I can't just do the regular Spring Boot, build an image, because I need to do a few tricks.
We have a couple of, we got to use the right JVM, and we can do that with the build pack. We can make it use the right JVM. We could do this part, except for the parameters where we're going to extract and when we do the extraction, right?
Yeah.
When we take that snapshot.
So it's basically based on what architecture you're on, because we need to pass that in, either ARM system or a Intel AMD system. So it pulls down the right JDK based on the architecture, sticks that in your Java home, and copies the app stuff in. And we have an entry point that's special for this experiment.
Yep.
So it basically checks if we find any CrAC files or snapshots in the CrAC files directory. It will, if it doesn't find anything there, it will start up the app, take a snapshot, and basically that closes down your app, and then we start it up again. And that should load it from the snapshot files.
Yep. So this one is saying, hey, I'm going to start up this app, and then there's that sleep 5. So hey, I want to wait a little bit. I'm going to let my app get up and running, and then I'm going to take that checkpoint, that JCMD process ID JDK checkpoint. That's where I'm going to take the checkpoint. It's going to write things down to disk. Fantastic.
And I create a little build script to make it easier. If I run it on my Mac or if I run it on a Linux box, it will pull out the right architecture for me.
I love it. I'm going to copy and paste that.
In. And I think it's called demo. Yeah. So I have everything that I went through in that little cheat sheet there. I already did that here. So I should now be able to just do run build. And you can see I'm on an ARM Mac. So now I just built my app, does the Docker thing, and it.
So
now it's ready. I got my image. I should just run it. And Docker needs a few extra things, capabilities added, because it's we need to enable checkpoint restore. We need to be netadmin, enable sysadmin. Otherwise, Docker will complain like you can't do these things.
You do such a good job of
Not
kind of
allowed.
highlighting some of those edge cases. Normally when I talk about it, I kind of skip over that stuff. You'll figure it out. But yeah, there are some additional properties and permissions that we need to give Docker in order to make this work.
So the same thing applies to if you want to run this on Knative. You have to actually tell Knative that certain things has to be enabled and you need to be allowed to do certain things. So now we see it started up in 2.1 seconds. It takes a checkpoint, which kills the app.
Yep.
And it starts it up again, and this time in 23 milliseconds.
Amazing.
Very cool.
Amazing. So when you start up in 23 milliseconds, you still have all the benefits. We can still go in and make changes dynamically. We have a JVM that we can attach our agent to. So we can still do all the things that we're used to doing with a JVM. But now we've got an image that starts up much faster.
Let's make sure there's something there. Yep.
Amazing.
We're live. And if I kill the demo, I run it again.
Amazing.
It starts directly
Even
from
faster.
the snapshot.
Does that say 4 milliseconds? Did that
Yes.
start up in 4 milliseconds?
It did.
That's amazing. That's just amazing. 4 milliseconds. So
can we get down to 2?
That's the case, and it depends. And at this point, it wouldn't necessarily be Spring or your the container that you're building. It almost, I think the bottleneck would be somewhere else. The disk that it's pulling from. Where is that image? Right. We probably have some other optimizations that we can make in order to get that startup time even smaller. This is amazing. We have
anyway. This is available in my repo on GitHub. So
yep, I put a link to the repo in the chat.
If you want to go try it out, let us know how it works out.
Take a screenshot. We want to hear about it. We want to hear how it goes.
Yes.
Look at this. GraalVM and CrAC both allow 50x faster startup time and scaling to zero. And it's not just scaling to zero, right?
Right.
Scaling to zero is just part of it. We want to be able to answer the call. We want to be able to respond when we need to. I was on a flight, was it last week? And I was actually using Knative serving on the flight. And I did a poll. I said, hey, go, check this out. Can you hit my application is running as I'm on the plane and doing my stuff. Can you hit this application? And I watched these applications scale up and scale down. How cool is that? But I was on a plane.
Yeah.
People were connected to my laptop on a plane and it was responding. And those milliseconds matter on those edge cases. So it's an exciting time. It's a great time to be a Spring developer. That's for sure. What else we got?
Hey, memory consumption.
Memory consumption.
So yeah, GraalVM allows. The tweet we saw earlier was way more than 3 times. So I guess it's app dependent. What
definitely app dependent.
Yes. And
it's definitely worth the experiment. So because we're doing these kind of things and we have some options, I like to encourage, take it for a spin, right? If you're the engineer, you're the platform operator, you're the person that says, hey, if we do this thing and we validated it and we can save, 3x of our footprint, we can reduce our footprint by, X, whatever it is. If you can be that person, then you kind of connect it to the dollars, you're going to get a pat on the back. You're going to get a thank you from your manager for sure. You might get a pat on the back because the benefits that we have, and this is why it's so exciting, all the things that are coming with Spring Framework 6 and Spring Boot 3. It's been an exciting time and lots of people are excited to pull their workloads forward to take advantage of these capabilities, these features. But you don't have to change the way you're delivering, put them in a pipeline, right? Get your images generated and then just test at the end, validate.
Another thing to look at is the throughput, right? So if you have a native image or you have a CrAC or you have a regular JVM, the throughput might vary depending on your platform and how you start things up. That's something to measure.
That is amazing.
And it looks like the community edition of the GraalVM, which is, I think that's 17, Java 17, right? So, and I think with the 21, it's getting better and more performant.
So you showed it kind of earlier how the JVM team continues to improve things. Spring team is continuing to improve things. We're in this mode. We're in this time that Java is coming out every 6 months, right? For those of us that have been around for a while, that's mind-boggling that we're going to have a new Java version to play with every 6 months. The Spring team is now releasing Spring Boot every 6 months, a new Spring framework every year. It's an amazing time. And the GraalVM team is going to continue to do their thing and make it so that I don't have a 4-hour build for my native images, right? Everything is continuing to move forward. And with this new cadence, yeah, there's some new things we have to do, but I'm going to encourage you, take these things for a spin. Get on the latest and greatest and see some of the real value that you can get, not just from scaling up and down, but actual running. Even if you're not doing the scale thing, your footprint could be improved, your performance could be improved, all these other things. And if you can get to the scale up and scale down for some of your workloads, man, it could be a great time. It could be a great time.
I can't wait for November where we get Spring 6 and
I'm not going to wait.
6.1 and 3.2.
I'm not going to wait. I'm going to take the release candidates for a spin.
All right. Yeah,
Thank you for using the milestone. And I'm going to encourage everybody else, take those release candidates for a spin. And if you want to know, hey, what do I need to do? Call me. I will help you understand what you want to take for a spin, some of the new features that are available. Yeah, let's do it. Let's all take that release candidate out and take it for a spin, see if it works. Do our tests pass? That's what I want to know. Let us know. I know Simon will. I know Simon will take it. A good moment to upgrade, given the end of OSS support for 2.7 next month. Yeah, you can be on 2.7. You could be on Java 8 still. That's okay. We're not going to judge. We want you to move forward. We want you to get on the latest and greatest. And it doesn't have to be that hard. So Ram Babu, I hope I said that right, says, so which one? One could choose, is it CrAC or GraalVM or Oracle GraalVM? You've got options.
Yeah.
Right? It depends, right? Our favorite saying, it depends. Take them all for a spin.
There's no size.
You tell us.
Yeah.
Tell us which one is going to work. And it's not hard to get here.
There's no one size fits all, right? So it depends on your app and what you're expecting and what you're trying to achieve. And I'd say definitely CrAC is more immature. So if you're looking to do something this week or next week, then the GraalVM option is more likely to be able to put in production.
I'm wondering, can I grab the screen? I'm going to give everybody a second. I want you to screenshot this. And Simon brought up a good point around the upgrade. I love this, and I'd love to take this for a spin. Can I? I'm going to see. Can I share screen? I'm going to ask.
Stop sharing.
Production here. I'm going to see if I can do this, and we're going to do it live. I'm going to share screen. I'm going to share an entire screen, and which screen is it? Is it this one? Let's try that. Let's see. I'm going to bump this up for you. Oops. Let's make this nice and big. Can you see that? How does that look? Can you read that? We're going to do a little live because Simon made a really good point. Hey, you've got to be on Spring Boot 3. You've got to be on Spring Framework 6. So what we'd like to do is I want to show you, it doesn't have to be that hard to get there. Can you see my screen? Thomas, can everybody see my screen?
It looks pretty dark. No, I can see your screen. Maybe you make the font bigger.
Yeah, I can make it even bigger. Right, so let's just do this. Wonderful. Let's do this. So I've got some JVMs installed, and this is my favorite demo to show because it's not that hard all the time. Sometimes it's going to be hard, but not all the time. I'm going to use Java 8, and don't try that. I'm not going to judge if you're on Java 8. A lot of people are still on Java 8, and yeah, it's a demo. So here I'm going to use Spring Boot 2.6. Spring Boot 2.6 is still in commercial support. So you might want to think about upgrading because commercial support for Spring Boot 2.6 is going to be done soon as well. I'm going to create a simple hello world with the web and actuator, just a simple Spring Boot app that I can start up and we can validate. So I use the curl. I got that from Ryan Baxter, our great host here. And here's what we're going to do. We're going to start it up, but we see it's Spring Boot 2.6. When down here, we can see it's started up, but because I've had actuator, I'm going to go and like, hey, validate it. It's up and running. I see this process ID. I'm going to use that process ID to get its memory footprint. So this application, Java 8, Spring Boot 2.6, is running in 364 megs. Cool. But we don't want to do that. We want to do the cool native things, and we want to be able to do CrAC and all that kind of stuff. So we have to upgrade. So here's what I'm going to do. I'm going to show you this cheat code. I'm using the OpenJDK plugin, and I'm going to use this upgrade Spring Boot 3.1 recipe, and I'm going to redo it. So the recipe's running. It's going to go do its thing, and it's going to take a sec. But this is looking at our code, and it's going to try to update. If you're coming from Java 8, all of your Javax to Jakarta, all of those changes are going to be made. This is a simple app, but this recipe works for a lot of apps, and I encourage you to go try this on whatever you're working on today and see if it works. There's going to be 3 things that you run into: your internal libraries, Spring Security is hard to upgrade, and Hibernate. Those are the ones that I hear about most, but you're going to have a lot of apps that are going to upgrade automatically just like this. It upgraded us from 2.6 to 2.7, from 2.7 to 3.0, and then from 3.0 to 3.1. So now I've got a Spring Boot 3.1 app, and I'm going to switch, because Java 21 is out, I'm going to switch to Java 21. And now I'm going to do the exact same thing. I'm going to start it up. And now look at my application is 3.1.4. So if you want to try all of this new native image stuff or the project CrAC, here's an easy cheat code to get you up there. And we can see, hey, it started up a little bit faster. Maybe we're going to see our application is healthy and running. Fantastic. And now look at our process here is 240. So this example, our memory footprint's a little bit smaller just by changing the JVM and the Spring Boot version. Fantastic. But again, we're doing the scale to 0. Like, what are the next steps? I'm taking a Java 8 Spring Boot 2.6 app. I run a recipe, and now I'm going to do the native compilation, just like you've already seen. But I wanted to show you, like, you can get here. It's not as hard as you think. Some of your apps are going to upgrade just as easy. Hopefully that helps. And if you need more help, call us. We're here to help. I would love for you to get upgraded, get on Spring Boot 3.1.4, and be ready to take Spring Boot 3.2, the RC candidate, which I think Simon pointed out comes out next week or Thursday. I'm going to go to calendar.spring.io on my other screen. Today is the 17th. Spring Boot 3.2. It's Thursday. It comes out on Thursday. Spring Boot 3.2 RC1 comes out on Thursday. Amazing. So questions over here in the chat. Would you want to showcase the use case kind of with some data illustrating CrAC Oracle? Yeah, we could definitely do a comparison. Rambabu, I will happily do a comparison of what it looks like for your workloads. Another question, isn't that GraalVM is very VM specific? Not all JDK can do like GraalVM, right? Versus CrAC will be the standard in the JDK. So that's a good question. Thomas answered. GraalVM provides its own JDK in addition to the native compilation. CrAC, if you're using something like Bellsoft, there's the NIC, there's the add-on that we can do for the native image. And CrAC on the other side, Azul is the only JVM today that supports Project CrAC. So again, it's trade-offs. It depends on what's on the menu. If you've got the option, you've got the capability to change your JVM version today, take it for a spin. So this demo, this simple one, right, it wasn't 3 minutes like it was for the pet clinic. This is a simple app. It only took a minute to do the compilation, which is about typical, minute, 10 seconds. But now my little app starts, it's still 3.1.4, and it started in 0.069 seconds. But I wanted to show you, here's the path. We can get you upgraded. I want you to get upgraded, and I want you to take these things for a spin. Try out Knative serving. Take your Spring Boot apps, build those native images, and run it locally. That's what I want you to do. This is great. Thomas, you gave me some cheat codes along the way. I know the whole getting the local image into my Knative, I need to do a better job, or maybe I need to switch to Kind and use that Knative simple startup. But I use GitOps, and I have all the other stuff set up. So I need to figure out how to do that right, because I do get that question a lot.
Yeah, you download the Knative's KN, the CLI. It has the quick start plugin, and it will start up a Knative for you in under 2 minutes.
Excellent.
You're ready to go, and you just tear it down afterwards, and it's all local.
That's great.
Perfect. Yeah.
That's great. That's great. So if we sparked your interest, if you like what you've heard, I encourage you to stick around, because my friend Mario is going to give you some even more tips on how to take this forward. First, you got to get upgraded to Spring Boot 3. 3.1.4 is the latest. Java 21 has been out for over a month now. Tomorrow, almost a month. Take these things for a spin. And then when you do that, take the RC for a spin. Give us feedback because we want to know how it works. Simon says, enjoy little things like sequenced collections and text blocks. Yes, like get all the benefits. It's not just that there's so much that you can get, but you got to upgrade first. I want you to be on the latest and greatest. Thomas, this has been wonderful. I like hanging out with you.
This is fun. Yeah,
I always learn.
We should do this more often.
We should do this more often. We should. Well, let's revisit it. Let's revisit it. Not Thursday. Everyone's going to take the release candidate. But after this goes GA, I think you and we should revisit this, and we should take some of these things that are now GA. I think we should take it for a spin.
Definitely.
This has been wonderful. Thank you so much. And thanks to everybody for joining and the great questions and feedback. Stick around because there's more to come.
And try things out from the repo and file an issue if you have problems getting it running.
Wonderful. All right, Thomas, thanks.
All right, thank you.
I'm gonna bug Mario. I'm gonna see if I can stick around and hang out with Mario a little bit. I'm definitely gonna be all up in the chat. Let's go.